Hey gang, we are in a different room today, as you can see. This is actually the IPT lab. This is the IPT stands for Integrated Product Team. That's the senior design class that PJ and I teach. This is the room where they have their class and stuff. This is also the room when we Skype with you guys, during your reviews, your payload concept review and your payload status review that we already had. This is the room that we Skype from. So we just did the video here today, mainly because I have a TV, and that's basically it. So before we, one thing we wanted to make sure we talk to you guys about is we're offering college credit for Inspires. You guys, every single student that's in Inspires right now has the opportunity. You guys can get college credit at UAH for Inspires, 1 hour worth of college credit. It's 1 hour worth of college credit is worth $427 at UAH right now. But you do not have to pay for that. You get it for free. You just need to apply for it, and it's yours. So, all right, I'm going to show you. This is the Inspires website, which I'm sure all of you recognize and have your like #1 bookmark and your favorite or whatever. I'm going to show you guys how to do this. There's basically there's a tab, or there's a link on the homepage that says credit, and that's not about credit cards, it's about the college credit. So basically, click this link, and there's this long paragraph that talks about the college credit, and then at the bottom there's an online form. Click this link to the online form, and it takes you to a new page, opens up a new page that is where you put your information to get the college credit. The reason we have a new page is because the information that we request from you, your name, your birth date, your social security number, a lot of that is basically sensitive information about you, personal information about you. And this form, this new page is secure. The Inspires website, not secure, but this page is secure. You can see HTTPS and a little bitty, there's a padlock up there. Your web browser should also be able to, you should be able to authenticate the security using your web browser as well. So the information is sent securely from this website and it's stored securely on secure servers. There should be no issue with that. But anyway, so it asks for your full name. There's a drop down for your high school. Select your high school. We've got all the ones that we're working with right now. Your mailing address, primary phone number, secondary phone number, birth date, social security number, primary email, secondary email, and then submit. And there's the security sticker at the bottom just to reiterate that this page is secure. So what this gets you is it's the class is called ENG 100. It's Engineering 100. It's Introduction to Engineering at UAH, and it's 1 hour of credit. And if you go to UAH, you could use this credit. Use this class, and it counts toward your credits to graduate. It's an opportunity for everybody. You don't have to take it if you don't want to, but I don't know why you wouldn't. It's free. It's basically you just spend 30 seconds putting your information in there, and you've got it. However, because it asks for your name, your full name, birth date, and social security number, I want you to talk to your parents first, make sure they're okay with that. If they're uncomfortable with you putting this information on a website, there is a PDF form on the same page. Back to the Inspires website, there's a PDF form at the bottom of the college credit page. And so you can read about it there. Some of the questions we get about this college credit, the main question we get is, will it transfer? The answer to that is we don't know, because transfer is not determined by the school where the credit is leaving. It's determined by the school where the credit is going. So if you go to Bama or to Auburn or something, will it transfer there? I don't know. We have only been doing this for a year now, so no one's tried it yet, to be honest with you. So we'll know more maybe after this year. But right now we just don't know if it'll transfer because no one's tried to transfer it. We don't know if Bama or Auburn will accept it. So I'm sorry about that right now, we just don't know. Anyway, but it's worth a shot if you want to do it, right? It's free, and it doesn't cost you a bit of money, just a little bit of time. And but please, 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 talk to your parents before you do this. Talk to your parents, make sure they're okay with you doing this. But then otherwise, do it, and you'll get a 1 hour college credit from UAH. All right, if you have any questions about this or anything, always, you can email me or PJ, and or you can talk to us when we're in your classroom. That is about it with this, so thank you very much. Bye-bye. Hey gang, yeah. By now, PJ and I have been to your class and we've talked about the engineering analysis. We've had what we call the engineering analysis review with your class. You've showed us the physics that y'all have done so far, and we've talked to you about it and told you what we think you should work on. Hopefully, if you have any questions about any of the stuff we've told you when we met with you, please email us or have your teacher email us, and we'll try to answer as soon as we can. But what we want to do, we're going to give, this is like a short video, and for me a short video, it's like 15 minutes. But it's a short video, but because we wanted to reiterate a few things, and mainly. It matters, as far as the engineering analysis, it matters more that you understand the physics of the problem than it matters how close you get to the correct answer. It matters how you understand the problem and all the variables and how they operate, then it matters that you get something that is close to the truth, whatever the truth is for your problem. So, which is why we've told you guys that you can use drag approximations. You can use all sorts of approximations that simplify the problem such that you can solve it by hand if you want to. But it's important that you understand what those approximations do to the problem overall. We want you to understand the problem. The Inspires is a competition. It's not a programming competition. It's not a competition about who can make the best plots or spreadsheets. It's about who can analyze their payload and explain it to someone else the best. So it's important to be able to explain in words and explain how you worked your problem. Be able to lay it out, and that's why we talked about the flow block diagrams the very first time. That helps you explain your problem. Something that helps explain your problem, how you pass a variable like velocity from one equation to the next, or from one part, one phase of the payload's operation to the next phase. Which variables are passed, which ones you continue to accumulate, like time. If you want to know the total lifetime, you keep counting time as you go through the different phases of the operation. So it's important that you can understand these things and that you can explain it to someone. So that's what you really need to practice. It's so great if you got the correct answer, but if you can't explain to someone how you got that answer, then it doesn't really matter. Someone else who got a less correct answer but can explain it better, they're going to win. Okay. So it's not about the absolute correctness. Yes, that's important, but it's more about that you understand the problem and that you can explain it to somebody. That way they know you can understand it, okay? Does that make sense? Is that good? PJ, is that good?
Yeah.
Awesome, sweet, okay. If you guys have any questions about any of this, again, send us an email, have your teacher send us an email, talk to us when we see you in person. But that's it for now. So thank you very much. Bye-bye.
Hey guys, so the majority of this video, since we just talked to you last week or so about the engineer analysis review, Matt told you a little bit more about that to make sure you got all that in depth. But the biggest part of this is to get you ready for the payload concept review, which will be in the next week or two after this video. Your teacher would tell you we kind of shifted some times and stuff to make everything work because this review is the practice for the final review, which will be here at UAH in the Shelby Center. So one thing you need to do, make sure and go to the Inspires website and go to the downloads page and download the Payload Concept Review template. Okay, it's out there for you to use. And so that's the template I'm going to tell you about today and what you need to do for it. You need to remember that this review is no more than 20 minutes, up to 20 minutes of time for you to talk, and then it's up to 10 minutes for the review board to ask you questions. I think for most of you, this will work. There could be some classes where we have to pull off some time, and we'll talk about that as we do it. Matt just told me they're all good in the whisper, and you didn't hear him because he was behind it. So I think you do get the ultimate, the maximum of 20 minutes and then 10 minutes. If you notice this template, it's not got just a few more slides than what the payload status review did, but now you're going to talk a lot more. And so we need to get you ready for that, for the final review. So again, on the slide, the first slide, right, slide number 1, which is also the title slide, you'll see, again, just like on the PSR, we have where you should put your team name, your high school name. Remember, take out all the stuff that's in brackets and put all that in there and put your logo on this page. I've marked it probably on everybody's thing. At this point, introduce, say, this is the Payload Concept Review. We are Team Blah from whatever high school, right? When you say your team name, explain it. Just go ahead and explain it right there. So that gives you kind of a nice segue into the whole presentation, okay? So do that, and that way it'll make everyone start to feel like, oh, they're cool. This is a neat thing to do. So do that. You have to start in the beginning showing enthusiasm too. So don't be all, hello, we're blah from blah, right? You've got to start with enthusiasm, because if you don't, the board automatically thinks you're not into this, you're not taking it serious or something. You've already given them a negative impression. You don't want to do that. Remember, this is extremely competitive this year. Both conferences are. And so you've got to be on your A game from the get-go, or you're going to not win. I mean, that's the bottom line to it. So that's the first slide. The second slide is a freebie. It's the agenda slide. You don't really need to add anything to it, or you definitely don't subtract from it, because it's got everything you need to. The one thing you need to remember, and all of you were very good at it, because I think I beat it in you in the first video at PSR, was make sure and change the team logo, put the team logo where it needs to go, put the high school logo where it needs to go. I think every one of you did that, which is a great job, right? So I did my job with the first one. See, I'm actually happier this time. I'm not as mad. Except, even though it's a Friday afternoon here at UAH, before spring break, by the way, I'm not that ticked yet. So we'll see as we go along how long you can keep me from being happy instead of going bad. So that's slide 2. So you just change those two, and on every slide you need to make sure the logos go in the appropriate places. Slide 3 is the team, right? And we've done this one before. This one should just look like PSR. Make sure and put the first and last name of every team member, and also their position, what they are, project manager, chief engineer, SEAL lead, whatever, whatever that is. And make sure and put the POC on there. Several of you put the POC on the slide, but you didn't say the name. Say the name, okay? And you can also say, we've contacted them, we've been in communication about this, blah, blah, blah. Give a little tidbit of information to show that you have been talking to your POC, so you understand what one of your customers wants, right? That's a good thing to be able to tell the board is, yeah, we've been talking to the POC, and they understand our payload and they are okay with it. That kind of thing. So make sure you do that on that slide. On slide 4 is your identity, right? So again, put the logo, the name, the slogan. And you guys did a really great job of that last time, but you didn't explain the connection between all of it, right? So, because it's somehow probably related to your science objective, your payload name, all that kind of stuff. Talk about that here, because this is the first chance they got to see a choice you made. And so this is the creative side of you. Remember, engineering is not very creative. And so you're getting to create and be creative with the artsy, stuff. And so do that here to make sure you emphasize that when you're doing it. It's the total package, right? So the identity is going to be a part of the package deal. The payload is a neat part of it, but your identity and how you market it is also important. And they will be very upset if you don't do it. The great teams are going to be the ones that can take the whole package and bring it to us. So remember that. Slide 5, this is the mission background one, right? You need to describe the UAH mission. We have given you a baseline mission. Matt has given you a presentation, PowerPoint, I think a video, all kinds of stuff about the mission that we here at UAH are doing, the baseline mission. You need to explain that in a little bit of detail to make sure everyone, because when you get to final review, no one will know what the UAH mission is, period. It's your job to be able to explain it to them, okay? In sufficient detail to where they can see how your payload is a part of that mission, right? So you got to tell them they're going to Venus. They don't know that. You've got to tell them all those things. There's primary science objectives as the UH baseline mission is. There are 3 elements or spacecraft that the UH mission has, and you can be on any one of them. You've got to tell them all that stuff, okay? And then you need to tell which one you're on and where it's going specifically. You know, if you're on the orbiter, it orbits the planet. It first does an aerobraking for 6 months, but then it comes in an orbit of 230 kilometers, right? Circular. Yes, Matt?
Yeah.
Yes. Yeah. And then there's the balloon. It's going to stay at 55 kilometers. The lander, all that stuff. You need to explain all that, okay? So remember that about this. Now, I will tell you, several of you at this point at the PSR got wordy, okay? Do not put complete sentences on this thing. Make it bullet points and get out, okay? Because if not, you're going to want to tend to turn and just read this entire thing to them. And they're not idiots, they can read, okay? So put bullet points, because that's your reminder of what to say. And you can look back and look at the bullet point and then turn back and look at the board, like I'm looking at the camera right now. But that's it. Don't do any more than that, okay? Because that just really makes them mad really quickly, okay? And no sentences. And remember, take out all of the template. All of this is the template, right? Get rid of all of that. All of this text that we have in there, get rid of all of it throughout, okay? So slide 6 are the payload design requirements, right? So we have project requirements. These are the things that we impose on you as UAH, okay? The 5 kilograms of mass, the volume, the no harm, the survive the environment, the autonomy. Those are the 5, okay? This is not a hard slide. Some of you made this really difficult at the payload status review. This slide is basically, we understand what our requirements are, okay? Because that's a big thing for an engineer in engineering, is we need to understand what our requirements are before we design something. So this is just a regurgitation of the requirements. So there's project requirements, and then there's functional requirements. There were 6 basic functions you have to do as a payload, okay? Deploy all the way to send data, house, contain the payload, right? There are 6 of them. Just list them here. You don't have to list what your answer to it, your solution to the requirement is. Right now, we just want to say, literally your presentation can say, we have 6 functional requirements. They are to deploy, they are to measure, blah, 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 right? You can get through this slide really quickly because you don't have much time. But this slide can be very simple, but you've got to tell us each of those things so the board knows you know what you're supposed to do, okay? And that is exactly what this slide does for you. Slide 7 is the destination, right? I think on every one of the presentations I saw, I said put a figure, okay? Put some figure of where you are going. If it's in the atmosphere, put the atmosphere. If it's on the ground, put a picture of the ground. You know, whatever it is, put a picture on here so people, because pictures are beautiful. You know, hurricanes, yeah, whatever. Yeah, hurricanes, all of it. They're all beautiful, you know, and so get some pictures. There's all kinds on the web, so you can do this. So you tell us where you're going, put the picture on there, tell us about that. And then you also have to tell us what the environment is like at the place where you are going. Don't give us the general environment of Venus. We know it is hot. There's a lot of pressure to surface, blah, 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 right? Give us the environment of where the payload is going only. Because this is actually the environmental requirements, right? On the slide before, on slide 6, you did project and functional. And on slide 7, you're giving us the environmental requirements. It's what you're doing, you know? It's very different to be in the hurricane than to be on the surface of Venus. So if your project is to go to the hurricane, don't give us anything about the surface, unless you're also going to the surface, okay? So make sure and get that correct, because that was a little confusion too in the last review. Science objective, give us the objective. Make it sound scientific-y, you know, make it sound really neat and just don't go pressure, right? You need to expand on the objective to make it sound really neat. This one can be a sentence. I mean, this is probably the one exception I'll let you have. Is it can be a full sentence. Now, don't you turn and read it from that PowerPoint. You better have memorized it to know when this slide comes up, you go, our science objective is to blah, 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 right? Do not read it to them from, you know, looking back at that screen. You look straight at them and talk about it, right? And the other part is the objectives are their importance. So what? What do we care if you measure the pressure in the hurricane on Venus? Okay, in one of the hurricanes. What does that matter? Who cares? You know, what does that mean to us? Why should we give you millions of dollars to do that? So that's what the importance is about, okay? So remember that. Some of you did a really great job of it, and some of you are going, it's important, you know? Don't do that. You know, don't do that. Do a great job at why it's important. And there's a lot of good stuff out there. There's a lot of research online. You can find some sources about this, okay? So don't cheat us on that one. Slide 9, the traceability matrix. That's all we need here, right? We just need that nice table that you will have filled out completely by now. Some of you had some TBDs. We don't want to see TBDs anymore. You can't even really have them at PCR. At the final review, you definitely can have them. But at PCR, you should know what this is now. You've got to have numbers. And so we need this thing entirely filled out, you know, and you can explain it in, here are the different science objectives, here's their measurements that we need, and here are the beautiful instruments that we need. You know, you can do this pretty quickly and go through like a line or two of them. You don't have to explain the entire matrix anymore, but you can give them a line by, you know, if you can see on the right, our objective is blah, 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 and then you can keep on going through it, right? Left, sorry. But that's the kind of thing that you can do with this one. So remember that. Likewise on this one, this is the instrument. So the last column on this table, right, should be the first column on this table, because that's the instruments. And what do the instruments require, right? Again, no TBDs, 0 at this point. You better have all that filled in, because we've got to make sure you understand what your instruments are requiring of you as the payload to do, okay? So again, that's how you can talk about this chart, is this is what the instruments require of us to be able to perform the science that we want to do, right? And so then you can go just a few lines, you know, again, this is the get through it faster part now, because the payload status review was 10 minutes and it's all about this stuff. This is more, okay, here it is, this is what it looks like. You need to explain it. Some of you would just go, there's our instrument requirements table, next. No, you need to say, as you can see here on slide 10, you know, the thermocouple has a mass of blah, which is blah, blah, blah. You know, you can say those kinds of things and do it quickly enough to go on to the next slide. So remember that for this one. Slide 11. This one was the most interesting one to watch in the first review, the PSR. What I think you should do more than anything is create a flow chart. How did you know now, each of you have 2 or 3 designs. You've each done it now, because we've seen it in decision analysis already. We've seen these designs. So how did you come up with them, you know? Did you split in teams and you each talked about it? You know, you each have a process or a method that you did to make this happen. Put that on the flow chart here, right? And then just talk about that to them. How did you get it there? How did you do it? You know, several of you created 2 designs now, and we've seen it, and you did decision analysis on it and realized a 3rd design would be better to take the best of both worlds. Put that here, okay? Give us all that detail, because that's the kind of neat stuff the board likes to hear about is, okay, they're thinking, you know? They realize there could be a 3rd alternative that would be better than the 2. And so that's all right. If you didn't do 3, don't make up another one, you know, to make that chart work. But then just talk about what you did, right? I'm amazed at how you guys can't tell us what you did, but you did it, so just put it on the chart, okay? And bullets are okay, but the flow chart, figures, engineers love figures, you know? And flow charts where things happen and this happens, that's like our thing, you know? So give us that kind of thing and that'll be a lot better chart. So here you're going to talk about the first concept, exactly like last time, right? So concept 1 goes here, you got the figure, because now you've all got figures. And then remember to provide the solution. So how does it deploy? How does it measure? How does it collect data? How does it provide power? How does it send data? How does it house or contain the payload? You know, by now you got that pretty much under control. Some of these were TBD before, not anymore. You're at PCR, it's over, right? Concept 2, same thing. But describe it, give us some details about it. What does it do? How does it work? Give the figure and then give the exact solution for what it does in these areas, right? If you have a concept 3, add it. I don't care. You can add a slide for that. But Beyond that, that's what you need on these two. Now you're in decision analysis, which is what we just finished with you, because we're getting ready to start engineering analysis with you. So in decision analysis, put the table you developed. We gave you a PowerPoint table already. You have an Excel spreadsheet, right? Put that here and talk about it. We talked to you about the fact that when you get here, you're going to have about 2 minutes to spend on this slide, we think. And so you need to explain maybe the 3 forms you created, but you need to also explain, because they don't know we gave you those other 7 and they don't know what they are. You need to explain those forms to them pretty quickly, some of the weighting, and then take them on a line, right? And show them what you scored for the 2 concepts. That's kind of, and you want to give them the takeaway, right? The takeaway message of, you know, we picked this because of blah and blah and blah is what we ended up doing. Well, this showed us that, right? And if you had some surprises, tell them that. If you thought going in, hey, concept 2 is going to win, and concept 1 won, tell them that. You know, tell them all the surprises or what you learned from doing this. That is the most important part. And remember, we told every one of you, the point to this is not the real number. It's the defendability of the why, right? Why did you choose that number? And are you confident in defending that to the board? That's what they'll look for, okay? And remember, they will come back to this at the end. When it's their time to question, you almost go back to slide 14 automatically, you know? So remember that one. This is a key chart for you. Next one is the payload concept of operations, right? And so this one can actually have multiple charts if you need. So when we say go, and this should be the one you have chosen, okay? This is what we're after here. The chosen payloads, concept of operations. This is where you begin to put the engineering analysis some in there, the numbers, right? Because now you can say, we deploy from the orbiter at 230 kilometers, we plunge in the atmosphere going such and such velocity, you know, we do this, we do that, and you can give numbers, right? And it's always a pretty drawing, right? Some sort of drawing makes this so nice, you know? And if you animate it, bonus, you know, where it's moving down, and like, ooh, cool, all that. You can do all of that, but you can use multiple ones if you go, okay, now we came through the atmosphere, and then the next slide is, all right, now we're in the atmosphere, and this happens.
Storyboarding.
Yeah, it's beautiful to storyboard it, okay? So that's here on these slides, right? And these begin to really tell them they know what they're doing, because you're giving them numbers too. You just don't say, we hit the ground, right? You're going to say, we hit the ground at such and such velocity, which gives us a G of this. You know, we hit the ground at 17 Gs, that kind of thing. Because now they're going, huh, that's some interesting stuff. Because now you've calculated and you can put that on here. So then you go to this one, right? Which is then, how did you get those numbers? And so it's a flow chart of the steps you took to analyze your design. We first did this, then that gave us this answer. Then we plugged that into this, and we got this answer, right? Don't put the equations and the calculations here. They don't care. They're going to assume the equations you use were correct, and your calculations are okay, because, and you can put them in backup. We call them backup slides. So after the last slide, you can put one called backup, and then have those behind it, in case they would say something in the review of, well, how'd you get that answer? You know, you can go to that backup slide and show them that kind of stuff. But don't put the equations here. It doesn't work with it. Just give them the flow of how this works. If you go and look at the presentations and the people that won last year, they all did this. Because everybody loves this in engineering. We love decision analysis. We like concept of operations. But this is calculations. This is when the geeks like Matt come out, you know? Because then they go, well, wait, you missed a step, you know? And that's what we're looking for, is to make sure you got all the steps correct when you're doing this one. So this one is, they love it, you know? It's kind of one of those things with them. So remember to do that. Slide 17, right? So now we're also talking about the one that you chose, okay? So what we want you to do on this one is called mass table by function. And so what we're after for you here is you can create a table, right? Put the name of your concept up here, put on this side function, deploy, function, measure, you know, all the functions go in one column, and then give us the mass by function for your concept. And then put at the bottom, after this one, total. And then put the total for the overall payload. Okay, this should be the mass that this payload takes, right? Because that number right now, unless you have requested a waiver, better be below 5. Okay? If it is above 5, you better have a star beside it saying, we have a waiver, you know, and you can show the waiver to the board, because that's very important to get the waiver in writing from UAH. So that's what we need. So there's another line called total underneath this one, okay? And so we want that because that's going to show that you have begun to meet your requirements, okay? Matt?
And how accurate should their masses be? To what decimal place?
1 decimal place is all we need. You don't know anything beyond that, okay? So like 2.1 kilograms, right? Don't go grams. No, you don't know a little paper clip. That's your problem. So remember to do that. So significant digits become a big deal. Likewise, back on this engineering analysis chart and this payload concept of operations, 0.1 on everything, tenth of something, right? Tenth of a meter a second. Actually, you can round off to 10 meters a second or whatever. But make sure and don't make it go crazy, right? And the numbers is not that, you're not that precise because we don't know that much at this time. So, we've done mass table by function. And so now we got requirements compliance on slide 18, okay? So what we want is a table that shows that your payload meets the requirements that you told us you had to do, right? So the project requirements, does it under the 5 kilograms of mass? Does it have the volume? Okay. Does it harm the UH spacecraft? Does it survive the environment? Is it autonomous, or at least part of it is autonomous? You have to show us all of that. In the environment, does it survive the environment? Is it designed for that environment directly? Under functional, deploy, all those, right? Show us all of those things to make sure you have check boxes. If you don't, that's okay. You've just got to tell us there are some issues we have, right? And those are the ones that you must get waived by UAH. So again, a waiver is very important. If you can't say, yes, we have met all these with this payload, okay? So that one's very important from our perspective. And then you've done that, right? You've told us all about the payload. Then last but not least, we need to know about that community engagement activity or activities that you did, right? So explain them. Give us lots of details, you know? Pictures. I can't emphasize this enough. Give us the pretty pictures of the cute kids, right? That you've been talking to about all this stuff. Provide proof of the events, the photos, right? And you got to summarize the results of the visitor survey. How many people did you get? Did you get to the 250? Did you go, hey, we went hog wild, we got 7,000 people, you know? Whatever it is, you got to tell us all that. And tell us some of the results of the surveys, you know? How much did they know about NASA? Things like that. We leave that up to you to tell us the details. But this one could also be a couple slides if you want to, because several of you have really cool CEAs. You need to tell the board about this, okay? We found out last semester the CEA ended up being a really big deal to the board. So they'd ask you a lot of questions about it. And one question they always asked was, what was the response you got from the people you talked to, right? So you need to have that in your back pocket, you know? You talked to some kids and they went, oh, NASA's cool, you know, or this is really neat, could you do some more with us, you know, that kind of thing. All of that needs to be right here in these slides, okay? So this is when the CEA wraps us up, right? And so to wrap up, you got to sell it, right? So you've told them all these details and you've been talking for 19 minutes. At this point, the brain's blown, you know? They got so much going on, they're going, oh my God, this is wonderful, but I can't remember everything else. So now what you do is summarize the design. Tell us what is really great about it. Why should it be chosen, right? What makes your widget so much better than anybody else's widget? What does it do, you know? That's what you're after on this slide. And show us a picture of it, you know? Put the picture here. I mean, if you don't have any other words on this chart, no words, you just put a big picture of what this is, great. Because then you talk about it the whole time. That's beautiful, right? Or you put some words if you need to do it. But this is the why choose us slide, okay? And that's what you've got to do. This is the end. You want to end with a bang, right? You want to be like, wow, that was a good team. They did a great job. Not a, ugh, that was bad, you know? So that's what we want on this one, all right? And I think that's it. So those are the 20 slides that we have for you to put in this review. This will end up being, like I said before, the payload concept review is the practice for the final review. What you're going to do after this review is change what we tell you to change and help you out there. Then you're going to change payload concept, you're going to type in final. And this is the same presentation you're going to give at the final review, right? You need to remember, and we will hold you to it this time, you can't have more than 20 minutes. This is a competition, and the government is with their requirements. You will do them exactly as required. So we need to make sure that you do this. So the 20 minutes is a hard cutoff. Some of you had a problem with the 10 minutes. You know, you took too long. That's okay, we only gave you 10 minutes. You got double the time now, but you got a lot more detail. This is the details presentation, right? We were more, oh, it looks like this, we're thinking about this. Now it is confident, we will do this, we're gonna do this, right? And now remember that in this. Don't ever say might or hope, right? We hope it'll work. Really? No, you know it will work, right? This thing will do it. You also need to remember, talk in the present tense, okay? I know this is a physics class or an engineering class, you want to stop with the English, you know, but present tense is important right now. This thing exists. You created it, right? So now it exists. It was never existed. It exists. It's right in front of you, you know? So remember that. And especially if you have anything to show people, it's going to be hard at the Payload Concept Review because it's through Skype. So you can't throw through the camera your prototype or stuff. But remember at the final review, you can show them things. And so that's the really neat part of this. So you can also do that as well. So I think I've taken long enough. My voice is about to go away. But remember, any questions you have, please, please, please email us. If you can, do it early. Get your Payload Concept Review. Remember, practice this thing beforehand. Send it to your POC. Ask for comments, okay? We will definitely, if you tell us we've sent our Payload Concept Review slides to our POC and they have not gotten back to us, like after a few days, we will put the pressure on them to come back and talk to you, okay? And to tell you what they think of it. So get feedback from them. Get feedback from your friends. Get feedback from total strangers. Go talk to your English class, your English teacher, and say, could we present this in class to your English teachers, or your English class? Hey, that's a CEA, number one. Two, it'll give you practice, because then your other friends in other classes can go, what the world are you talking about? I did not understand a bit of that. Didn't you know there's some problems, right? So practice, 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 okay? And as always, you can always email us, and we'll get back to you. Talk to you soon. Bye.